I guess first up, thank you everyone for joining us in person and on Zoom. It's great to see a good crowd of people here in person. This has been, it's not since 2019 that we've actually had this meeting in person, so it's nice to see everyone back again. Before we get started, we do have a code of conduct that we established as part of the Parcel project. We don't yet have one for FunkX, but we can assume they're the same. This is in the Parcel GitHub. It's listed here. Any issues, talk to Dan over in the corner here. He will be able to sort you out. Anything you want to say about code of conduct beyond that? No. Okay, so this is just a quick picture of our meetings. So as I said, we started this meeting in 2019 with an in-person event in this room, I think, actually. Was it? Is anyone here? I think it was in this room. And then, of course, due to the pandemic, what's that?
We're going the other way.
Yeah, it was facing that way, yeah. For some reason, it's now oriented this way. Over the last couple of years, of course, we've had to take everything online, which I think has been sort of good and bad. It's been good in that we've been able to engage a much wider range of people, and bad in that we haven't been able to see each other in person, but I think it's actually worked quite well. And we see this year we're trying our first ever hybrid event. I think, again, hopefully this combines the benefits of both methods, but it's nice to see a roughly equal division between the two groups. And we would like, I had to search around for this 2021 photo this morning, so we would like to take a couple of photos during this event so that next year I can add another loop to this slide. I thought I should also start by introducing the Parcel and FunkX team. So some of these people, maybe a little more than half, are actually in the room today. Both the Parcel and FunkX teams include a fairly large number of people that do various things. If you see these people at lunches, etc., feel free to talk to them. Talk to them about problems you're having or suggestions you have for ways we can improve either of the systems. There are a few that are probably in both projects, but some that are also only in one. And I ran out of space, but there's also some other contributors that have really helped us get to where we are today. I should also say thank you to the funding agencies and the project partners. So both Parcel and FunkX are primarily supported by NSF, as we'll talk about in a bit. We have a number of NSF grants that have helped Parcel here. Really, these are two grants, but they're collaborative, so they get split over a number of organizations. And then FunkX, we have a collaborative grant as well. Of course, this is a UChicago Argonne project, but also it's a UIUC project with Dan and Ben and others from NCSA that contribute a lot to both projects. And then we have a bunch of other partnerships down the bottom here through Argonne and through other mechanisms like DPI that support Parcel development, that help to, and FunkX development, and help to fund applying them to various application domains, anything from cosmology, which we'll hear about, the desk group that have supported us throughout, to material science, to funding from ALCF, etc., that have helped us be able to build these two systems. Ben Clifford, I'm not going to read the chat. If anything happens in chat that I should respond to, can you let me know?
Okay.
So I just wanted to as well highlight the growth of these two projects over the last 5 years. So we started Parcel exactly 5 years ago in 2017, and you can see here that we're basically on any metric growing. There's one asterisk where some less than competent programmer, me, who was setting up the Google Analytics, accidentally copy and pasted the Google Analytics code across a few websites. So the orange bar gets a little hairy in the middle there. It's now fixed, so you can assume that 2020 maybe that growth in the website traffic was a little bit different. But the things we really care about, I think, the number of downloads, the blue bars here, is really growing exponentially. Helps, of course, that FunkX as well as, of course, using Parcel for how it speaks to resources. And the other big one we're really happy with is the red bar, which is the number of contributors. So it's great to see the Parcel project reach 70 contributors. I think we are very thankful for the many people out there that have contributed anything to the code base, from documentation, test cases to core code. And please, if you haven't contributed to Parcel in the past, it's completely open source, very friendly community mostly. Feel free to submit pull requests. We're always willing and very happy to accept them. And then on the FunkX side of the world, of course, a little bit newer. We started in 2019. We went through a few prototypes. But we're now really starting to run with a full-scale production system. And you can see there almost exponential growth in terms of the number of users, the number of endpoints, the number of functions, and the number of tasks run. So I think yesterday we passed 20 million tasks that have been run through the FunkX system. So that's a pretty encouraging number, particularly as really we've only been pushing on sort of not friends and family use for the last year or so. So really a lot of that growth has happened as we've started expanding out. So goals for this meeting. So the goals really are to bring the communities together, particularly in the open source sort of model of developing these software technologies. So it's good to have people together. We'd like people to be able to interact and share experiences using these systems and technologies. We'd like for people who are users to be able to voice problems they've run into, maybe compliments as well of things that have worked well, but be able to speak to the people that are actually building these systems and be able to help orient the direction of these projects over the next few years. We go through sort of periodic road mapping exercises every 6 months or so, and it's great to have features that we can link back to a specific person or group of people that actually want that feature. It really helps us prioritize the type of work we're doing. We'd love to see new collaborations. We've seen that in the past, that people have met other people here doing similar types of work, and it might be in terms of the domain science that they're working on, it might be in terms of the technology they're building, and hopefully we get new collaborations and potentially even new contributions to these systems. So I wanted to, I don't know how we're doing with time, but I wanted to quickly do a run through of what is Parcel and what is FunkX for those that are maybe familiar with neither or with one or the other. And I'll try and keep this very short. Feel free to interrupt if you've got any questions. So just quickly, motivation for why we're doing this. So our group has been working in the sort of parallel computing, well, probably generally since Ian got his PhD working in parallel computing, but in the early 2000s, starting with workflow systems, the Swift workflow system that people know, moving to the Parcel workflow system, which sort of tried to take a lot of Swift and move it to Python, into FunkX, which really tries to servicify Parcel and make it very easy for remote computing. And so when we started on Parcel 5 years ago, we sort of looked at what does the research computing landscape look like, and what are we working with here, and what are the problems we're trying to address. And so the first thing is that we see that a lot of research software is really assembled, right? So people aren't writing everything ground up. They're coupling together a bunch of components and trying to mangle them into an application that works together. And that might be orchestrated as some sort of workflow. It might be orchestrated as a bag of tasks, some sort of more sequential model. The second thing we see is that parallel and distributed computing is increasingly ubiquitous, right? I mean, we're seeing, it used to be the high energy physicists were the only ones using these big machines. Now we're seeing social scientists and very broad domain scientists needing to use large scale computing to be able to achieve their research goals. A lot of that's because big data sizes are increasing. A lot of it is also because of the end of Moore's law and the slowing of sequential processing power. And then sort of as a 1B to that, we also see this need for heterogeneity. If we're trying to get the most out of our resources, Ben can probably speak to this with his Samba Nova hat on, we need to have customized architectures that are really defined to deliver high performance for particular types of workloads. And if we start thinking we have very specialized resources, almost by definition, that means we have distributed resources. Almost by definition, we have applications that are going to be best run in different types of resources if we break it up into different parts. And then the last thing, I think this has really resonated over the last 5 years, is that Python is sort of the de facto standard at the moment and has been for probably the last, can you say half a decade? Last half a decade in terms of adoption. So we see, again, general adoption of Python as this higher level orchestration language that combines components written in other languages. And I think it's really resonated with the research computing community, being able to write their codes in a language that's probably easy to learn. Yeah, some people on the line will probably complain about lack of typing, et cetera, but it enables people to get ramped up quickly and be able to build their workflows. So in a one-line sort of sentence of Parcel and FunkX, Parcel is really about trying to encode and represent parallelism in Python projects. FunkX is about building a servicified version where we can fire and forget these computations, outsource them to an entity in the sky to be able to manage the execution of those. So Parcel, this is the one slide we've given 1 million times that outlines the sort of basic Parcel model. So with Parcel, we've tried to stay very close to Python. We've augmented it with a couple of constructs that allow people in a Python script to be able to represent opportunities for parallelism. We do so with these annotators, these decorators on top of functions. You decorate functions that could potentially run concurrently. You then string them together with common Python code to be able to establish a directed acyclic graph of data that needs to pass between applications. We think this is a very nice way of being able to represent parallelism. It's an easy way to think about constructing parallel applications. And then we have a runtime system in Parcel that can take this representation of a program as a DAG and be able to run it on whatever resources we have it connected to. We're focused very heavily on making an abstraction layer, or 2 abstraction layers actually, that separate the specification of the program from the actual way it's executed or the way it's run in backend systems, enabling us to move between different schedulers, clouds, container orchestration systems, etc. This is just a quick diagram showing an example from our COVID work a few years ago about how this data flow based model, where you can sort of implicitly compose these graphs of dependencies between linked functions, is a natural way of being able to orchestrate big parallel applications. And we have support for different types of data flowing between the applications, anything from sort of standard Python objects through to files that are orchestrated with protocols like HTTP and Globus to move data between things. In terms of our highlights over the last year, so if you were here last year, you would have seen probably a similar 2 slides, probably presented by me. I don't remember, but probably that happened. In terms of what's new in the last year, so the big thing is that we have a new award that Dan's going to talk about. We actually have another award that's going to be coming as well soon, but that's not yet announced, but we'll focus on this one today. So we have an NSF award that really is interesting in that it focuses entirely on sustainability. So it was an interesting opportunity for Dan and me to write this thing, because it was not like our normal NSF proposal where we talk about interesting tech. We talked about things like governance and sustainability and community and aspects like that. All the technical was more about maintenance and testing and really sort of stuff to try and make the code base easier for us to manage as a community. In terms of code updates for the year, there's a bunch of things we've also done. We'll hear a little bit about this. Work queue executor, I saw Ben Tovar on the line from Notre Dame, but that's now become a production executor for us, and one that we use in a bunch of different scenarios. We have a bunch of bug fixes. We have a bunch of interesting collaborations that we'll hear about. ExaWorks, I think Dan's up first. Radical, we're going to hear about from Eamon. So a bunch of collaborations with different groups that are bringing new capabilities to the Parcel ecosystem. As I said before, in terms of community, our contributors are up to 70. We have a meeting every fortnight or bi-weekly, which we advertise in our Slack channel. It's completely open. We talk about whatever the community wants to talk about, so please feel free to join us if you have things you would like to discuss. I need to hurry up, don't I? Because we have 4 minutes until we need to get to the first of our sessions. So FunkX, as I said, one of our biggest roadblocks we ran into with Parcel was this need to be able to coordinate workload across many resources. And we had solutions for this using SSH connections to be able to sort of dial into resources and run things concurrently. But that was always very fraught with problems because these SSH connections are fragile. There's the auth issues, et cetera, et cetera. There's how on earth do you communicate between the 2 remote systems, et cetera. So what we started to think about was how can we develop an agent, sort of invert the Parcel model such that we have agents sitting there on these remote resources, and then we use a cloud-hosted service to basically enable us to fire and forget, to be able to orchestrate workload across all of these different resources. And we benefit there from the advantages of reliability, robustness, security, et cetera, that come with having a cloud-hosted service. So the model we've taken is a functions as a service model. We're essentially registering Python functions with the service in the sky, and then we're allowing that service in the sky to be able to fork or push those workloads, those invocations of those functions to the edge endpoints that are deployed on remote computers. We leverage very heavily the Globus model. We're, of course, part of the Globus group. FunkX is part of the Globus group, and Vas can probably speak to exactly how that relationship is working. But FunkX is an early product that I think will hopefully in the near to medium term become a Globus product. And so we've leveraged a lot of the expertise, a lot of the approaches to how we model the cloud-hosted service, how we operate the cloud-hosted service, et cetera. I'm going to skip these 2 slides given where we are with time. That's just digging into how FunkX is actually working. Some highlights for 2022. And so maybe some of this is less visible because a lot of our work has actually been on the cloud-hosted side, but and Yadu will speak a little bit about this, I think, later today. Well, we've gone through some fairly major changes to the FunkX architecture. I'd say we've basically rewritten the FunkX architecture in the last year to make it much more scalable, reliable, secure. And Yadu will dig into that. We've moved towards an executor interface, so using the concurrent futures executor interface to enable registration and execution of functions on the fly. We've moved to a new S3 based model for storing tasks, which enables us to store your tasks and your results for much longer. It's actually just results. Enables us to store your results in the cloud for much longer than we did previously, and also allows us to store much larger results than we did previously. We've done a bunch on the security side, on the token side with the new Globus SDK, and we have a new sort of internal lifecycle model and logging model that allows us to much more quickly now debug when there are problems. And we're hoping to work to expose that actually to users as well, so you can ask questions of your FunkX executions. I should also say 2 community things for those of you that are generally interested in the workflows community. We have a workflows community initiative that is led by Rafael Ferreira da Silva out of Oak Ridge National Lab. As part of this work, we have a BOF at Supercomputing. We'd love to see many of you actually join us there. And we're also going to hold another community summit. We had 3 community summits last year in the workflows community that you can see in the bottom there that attracted, I don't know, 120, 140 different people from all over the world. So we're going to have another one of those in the fall. Information is on the workflows community website. Okay, so we've got, as I said, we keep adding talks. Ben or Yadu kept telling me to stop adding talks. I kept adding talks, so we've actually started to shorten time as we go. We've got 31 talks over roughly, I don't know how many hours, probably not many, 5 or 6 hours. So they're going to be very short talks, 7 minutes. Someone is going to police that very diligently, the chairs of each of the sessions. And then we're going to leave a couple of minutes for questions. So I apologize if we rudely cut you off during your presentation, but given we have so many talks and so little time, we're going to have to keep people on task.